Okay, let's go over evaluating limits algebraically, and I want to talk kind of fast because some of these examples get pretty long. But you can watch it as much as you need to, so it's there for you. All right, looking at the example in orange, the first thing I want to try is evaluating this to see if it works out, because if it works out, then I don't need to do anything else, and we end up with nice numbers, and everything turns out pretty. So since I'm evaluating, I can drop the limit. And I'm substituting in 1. That's what my x value is approaching. And when we simplify this, on the numerator, we get 1 squared, 1 plus 5, 6, minus 14, negative 8, over 1 plus 7, which is 8, which is negative 1. Okay. And boom, we're done. We found our limit for that function. Now, moving on to the example in purple, again, we'll try evaluating. We get the square root of negative 1 plus 1 over 1 minus 1, which gives us 0 over 0, which we know is indeterminate. So, this doesn't tell us if our limit exists or if our limit does not exist. It just tells us we need to do something to this. So, what I'm going to do is I'm going to rewrite my limit because I'm no longer evaluating. And I'm just going to start with this square root of negative x plus 1 over x minus 1. And on my numerator, I only have one term. This whole thing right here in orange, that is just one term. So I'm not multiplying by the conjugate, because the conjugate is when we have two terms, when we have binomials. All I'm going to do to rationalize this, because my strategy here is rationalizing, is I'm going to multiply by that exact same thing. So the square root of negative x plus 1 divided by the square root of negative x plus 1. And then we can simplify limit as x approaches 1 because we're not evaluating, we're simplifying. And we get negative x plus 1 divided by x minus 1 times the square root of negative x plus 1. Okay. Now, I don't see any common factors on my numerator and denominator that I can simplify out immediately yet, but I do notice that I have a negative x plus 1 on my numerator and an x minus 1 on my denominator, and those are the same terms. It's an x and a 1, just with flipped signs. My x on numerator is negative, denominator is positive. My 1 on the numerator is positive, my 1 on the denominator is negative. That means if I factor out a negative 1, I'm left with negative x minus 1. Is that right? Yes, that's right, okay. Sorry, my brain decided to stop working for a second. And I'm forgetting to do something. Hopefully you were screaming at me in this video, telling me, you didn't write the limit, you didn't write the limit. I didn't write the limit, and I need to write the limit. So we have the limit as x approaches 1 over x minus 1, square root of negative x plus 1. Okay. And now we have a common factor on our numerator and denominator. Those simplify out. We're left with the limit as x approaches 1 of 1 over the square root of negative x plus 1. And now I can finally evaluate this. Sorry, I'm taking a detour to make sure my thing's long enough. Okay. And we get 1 over the square root of negative 1 plus 1, which equals 1 over 0, which 1 over 0, this will actually become, let me zoom out a little bit if I can. There we go. This will turn into something later, but for now, I'm just going to focus on saying what it is. 1 over 0 is undefined, but we are doing a limit. Limits are not undefined. They either exist and have a number, or they do not exist. So this implies that our limit does not exist. By the way, if I ever write this arrow right here, I'll put it up. I do it like that. That means implies. That is how you read that arrow. And I could talk about implies all day. It's one of my favorite symbols, but to stay on topic. Okay, now our bottom one. This is a number 13. This is the last one on your quiz review. And this one is a bit of a doozy. We need to be very careful with how we approach this. So, I have the limit as x approaches 0 of 4 divided by the square root of 1 plus x minus 4 all over x. And if I tried to evaluate this to make it pretty, I have 4 over the square root of 1 plus 0, that's 1. 4 over 1 is 4. 4 minus 4 is 0. If I substitute a 0 in for the denominator, we get 0, so we have 0 over 0. So we cannot just pull a number out. So we are indeterminate. So I'm going to skip showing that it's indeterminate because I just verbally went through it. And we're going to do a lot of things. So again, I'm going to start by writing my limit as x approaches 0. And you sort of have two approaches here. You could do this one of two ways. And if I have time, I'll show both ways. But I think actually the easy thing to start with, well, you have two approaches here, because we can see that we have fractions that we need to put together, so we need least common denominator. And you also see that we have a radical on our denominator. I'm going to start with least common denominator for no particular reason. You could do either one first, but just because that's what sounds nice to me. And so we're going to have 4 over the square root of 1 plus x times, well, our second fraction isn't even a fraction, so our denominator is 1, so times 1 over 1, minus 4 over 1 times the square root of 1 plus x over square root of 1 plus x, all over x. And we simplify that, we get 4 minus 4 square root of 1 plus x over the square root of 1 plus x over x. And I made a mistake again. Hopefully you were yelling at me, saying, where's the limit? I did not write the limit. We have the limit as x approaches 0 of this function. Okay, and now we can simplify our denominator, and that's the easier one to simplify. Well, in my opinion, it's the easier one to simplify because I just know that these denominators are going to end up multiplying. So we have x times the square root of 1 plus x. And if you look at our numerator, both of these terms have a common factor. So I can factor out a 4, and we get 1 minus the square root of 1 plus x. And now we get to our favorite friend with radicals, and this is actually going to come up again when we get to trig functions. But we now need to multiply by the conjugate, because my radical term, or my grouped terms, these here, is a binomial. So I want to multiply this by the conjugate. So I'm going to multiply by 1 plus the square root of 1 plus x, divided by 1 plus the square root of 1 plus x. And I'm actually going to come back to the left again here, and so I'm going to go equals our limit as x approaches 0, 4 over, and I'll write the denominator and then I'll write the numerator. We have x times the square root of 1 plus x. I'll call that, really that's 2 factors, so I shouldn't group it like that actually. I should group each factor individually. So we have x times the square root of 1 plus x times 1 plus the square root of 1 plus x. Okay. And then on numerator, we have a difference of squares. So a squared, 1 squared is just 1. So we have 4 times 1 minus, and then b squared, well, the square root of 1 plus 6 is, or 1 plus x is just 1 plus x. Make sure to group that because this negative is going to have to distribute to the 1 and the x. And then we can simplify our numerator, and we can write it as 4x, right? 1 minus negative 4x. Sorry. Negative 4x over x times the square root of 1 plus x times 1 plus the square root of 1 plus x. Okay. Common factor on the numerator and denominator. They both have an x in them, so we can simplify that out. And then we get the limit as x approaches 0 of negative 4 over square root of 1 plus x times 1 plus the square root of 1 plus x. And now we evaluate. We get, and since we're evaluating, we can drop the limit finally. Negative 4 over the square root of 1 times 1 plus the square root of 1, which equals negative 4 over 2, which equals negative 2. And there's finding our limit algebraically. Hopefully I didn't make any mistakes. I did it the same way. I don't think I have time to go over the other way, but I invite you to try it as an exercise. Try rationalizing your first fraction first, and then combining like term, or finding a common denominator and combining your terms. And see what happens. See if you get the same answer. All right, hopefully this was helpful, and bye.